Hello everyone and welcome to today's tutorial on how to build MCP server. So guys, if you don't know about what exactly an MCP is, watch our video on MCP tutorial at Simplilearn channel. In this video, we are going to learn about what exactly is MCP. Then we are going to simulate a real world mini project building a food ordering application. So in this, first we are going to set up our folder structure. Then we are going to set up our model layer. Then we are going to set up the context layer. And finally, we are going to build our protocol layer. So guys, if you're interested to understand what exactly MCP is and how you can build MCP server, then watch this video till then. Now, before we move on, here are 5 basic prerequisite questions which you should be comfortable with before watching or building along with MCP style food ordering app in this tutorial. So our first question is, what does a Python class define? And your options are A, loop, B, condition, C, a data blueprint, or D, a print statement. Next, which keyword is used to create class in Python? Function, class, def, or import? Next, what does input function do in Python? Show output, creates file, takes user input, or runs forever. And final question, how do you import a function from another file? Copy from file, move file, from file import function, or use file function under parenthesis. So guys, mention your answers in the comment section below. Let's get started. So let us first start with understanding a basic simple food ordering app like Zomato. So you can take that as a small prototype. So imagine like you are the user and you open the app, and there are few basic things that we will be doing. Let's say first we are logging in, okay? Then in the next feature, we can browse a restaurant. In the third feature, let's say we are choosing a food item. And in fourth, let's say we are checking the order status. Now, behind the scene, the app has to handle all of this smoothly. It needs to remember who you are, know which restaurants exist, accept your commands like order pizza, track your current session like whether you are logged in or not, and give you a clean response. If we are building an app like this carelessly, then all the logic, data, rules, status, commands would be mixed together. And also, it would become confusing, hard to maintain, and prone to bugs. This is where your MCP comes in. Let's break the entire system into 3 clean roles. Okay? So let's say the first one we have all over here is called model. We can say model as the memory. Now, if I talk about the model, okay, think of this as the menu book or the order register. It contains the list of users like a guest list, the list of restaurants, menu of each restaurant, and also order placed by the users. This doesn't make decision, it just stores information. For example, let's say a user registered, okay, and Domino has pizza and pasta as the menu. Now, if I say like Domino has pizza and pasta as the menu and the user has ordered pizza from Domino. So this is what your model is, okay? This is what is storing as a memory. So you can just imagine something like this. This is where all your data lives, okay? You can think of it as a menu book. It doesn't make decision, it just stores the information. Now, if we talk about the context, now, let us try to understand context. So context, you can understand something like this as a session memory. It knows who is currently using the app, what they are doing right now, like browsing or placing the order. This changes frequently. For example, when you log in, the context is going to store your name. When you order food, the context is going to store the current order. So it's like a screen where you see your app and it changes based on what you are doing. So let's say we have a current user named, let's say Alice. And It could remember the context in a sense, like the current user is Alice, Alice's current order is pending, and no order placed yet. So something like this in the format of our given application, we can consider this as the context. Now let us try to understand the protocol, which I would also say that this is the brain. So protocol is the logic. It's like the brain that receives your command, like login Alice or order pizza, and it decides what to do. Like it looks at what you said, it checks the context, meaning are you logged in? It interacts with the model, like is pizza on the menu or not, and it updates these things and gives back the response. You can understand something like this as the manager of the given application, deciding what to do when something happens. For example, you can think when user says order pizza. So the protocol checks first, is the user logged in? If yes, then place the order, save to the model, and also show that pizza ordered from Domino. So let us walk through the quick glance what exactly is happening if we discuss about model, context, and protocol. So let's say when a user opens the application, okay, and let's say the login is username Alice. So protocol gets the message like login Alice. It is going to check if the user exists in the model or not. If not, then create that particular user. Then it updates it to the context saying like Alice is the current user, and it responds back welcome Alice. Next, the protocol is going to check if Alice is logged in using the context. Then it checks if pizza is on the menu using that particular model or not. If yes, it places the order, updates the context, and stores the given model, and returns the response that order is placed, like you are getting pizza from Domino's. So if I talk about in definition what MCP stands for, so it is basically Model Context Protocol. And I just showed you a very basic example using this food ordering app where how your model context and protocol are working. So MCP is basically a software architectural pattern that cleanly separates an application into three parts. That is model, which stores and manages the data like users, restaurants, and order in this context. And then there is context, which tracks the current state of interaction, like who is logged in or what they are doing right now. And then you get protocol, like it is a processes which takes user input, makes decision, and coordinates between the model and the context. So basically, MCP pattern helps to build organized, maintainable, and scalable system, especially where their interactions are kind of stateful and also message driven, like food ordering apps, chatbots, or multiplayer games. Now, you'd be wondering why to choose MCP. Okay, there are a few very basic reasons. First of all, the core goal of using this protocol is that it keeps your code organized. It makes it easy to add more feature, and each part does just one thing, like there is less chance of the bugs. And also it is great for apps with users, commands, and sessions. Now, this is an overview picture of MCP protocol. And what could have been the best way? Let us try to build something using MCP. So that would give us the clear context of how we can use it in a given application. So here is a small mini project. Let's start it. Now guys, let us simulate the same example and build a given project. So this is our project structure. We are going to have model.py, context.py, data.py, protocol.py, and finally our main file app.py. Now you can see the best way to first start is by creating a virtual environment, which I've already done it. Okay, so this is .vnb. If you are unaware how to create a virtual environment, then just go to Google. And this is the official documentation of Python, where VNV will stand for creation of virtual environment. So you could see this is the way to create a virtual environment. Just read this documentation. So basically it says Python MVNV, and this is a given path to the new virtual environment. So for example, like C path to the new virtual environment. So I have already done this. You could also do the same thing. Okay, it's very basic. And let us start by understanding our given code. So in this, we are having the data models or object, and this file defines the things that our app will work with. For example, here you could see we have a class user, we have a class restaurant, and class order. And we have defined the constructor for the same. So here you could see the instance name is username. Similarly, if you could see on the restaurant, we have initialized this, our constructor, self, name, and what are the menus available? Very basic, self.name equals to name, self.menu equals to menu. Guys, if you are seeing it for the first time and you are unaware about the syntax of Python, then do check out the Python full course at Simplilearn's channel. Now, let's also look at this class. This is called class order, and you could see it has initialized the constructor, self, user, item, and the restaurant. So it's like self user user, item equals to item, self restaurant restaurant, and the status we have default given it as pending. So this is the initial state. Now this is where the data or the model we have created. So you can see also there is a symbol that's created. So that shows us that what our model is. Now let us try to understand the context.py. So basically, this is a file that keeps track of what currently is happening, like who's logged in and what they are ordering. So you could see first we have created the class session context. Okay, so this is the name of our given class, and these are our given instances which we have initialized the state. Let us say the logged in user, nobody has logged in, so I have kept it as none. There is no current order, I have also kept it as none. Then we have initialized a function login, and with user as one of the parameter, and we are checking it that if self logged in of user equals to user, then this shows that you have logged in. So when someone logged in, it stores the value all over here in self.loggedin/user. Now there is also a function that I've created, logout. Okay, and if I talk about logout, we are pretty much clear, okay, all over here, like the user and with their order. So initially the state of self logged in user is none, and the current order is not placed yet, so we have kept it none. Now next, if we see add start order, okay, so when a new order is placed, we store it all over here, okay. Then next, if you could see get user and get order. So these two functions just return who's logged in and what's the current order is. Okay, so you could see return self.loggedin user, self.current order. Okay, so this is the current context that we have created with respect to our given model. Okay, so we discussed about this in the starting in a given food ordering app, how we are going to store the context. Similarly, I have simulated all of these things in our given programming. Now let us try to understand like the additional thing that's we have added, that's called data.py. So it's like a sample restaurant data. It's like a mock data, you could understand. We have used this to preload some of the restaurant menus. Like for example, if I would say from model import restaurant, dev get restaurant, and return like first Domino's, this is a restaurant, so we have pizza, garlic bread, Coke, then there is Burger King, burger, fries, Pepsi, then there is KFC, chicken bucket, ginger burger, and 7-Up. So these are some of the basic menus we have added based to the respective restaurant. Now let us understand protocol.py, which is actually the most important file. This is called the brain. Okay, so you could also see we have imported context, okay, session context from context, then get restaurants from data, and MCP protocol from the protocol. Okay, basically this file is going to handle all the command, the user types like login, order, status, etc. So we have imported these data models so we can use them here. Okay, now you can see all over here we have defined our class MCP protocol, and we could say this is definite, self, context, restaurant, data, and user list. And finally we have bounded it. Okay, this is just like creating a constructor for this given class, and these are our given parameters. So in this we receive a context to check who's logged in, okay, the restaurant data basically to get the list of all the restaurant menus, okay, and user list to check like who all are the users who are logged in during this session. Okay, then also next thing, like we have also created a method called diff handle. Okay, so it says if the message starts with login, okay, then you are doing what, username equals to message.split and then one dot strip. Then we have also appended the given user, and we have also updated the context of the login. And finally, we have returned logged in as username. So basically, like for example, you could understand something like this. Let's say if a user Alice types something like login Alice, so it extracts basically Alice from it, creates a user, logs them in using the context, and then it's going to return the given message. So this is how this is handling. Okay, so this is adding a given user with the help of the context. Okay, so this is one of the very important method that we have to create. Okay, now if we look at all over here, so we have elif message starts with an order, if not self.context, get the user, and return please log in first. So you can see the code and understand this context, like if no one has logged in, they cannot place an order. Then I have written parts equals to message.split one strip from. If the len part isn't equal to 2, then use format order item from the restaurant. So basically the overall idea for this code is that we expect the user to type something like order pizza from Domino's. Okay, then we could see item 0 dot item equals to part 0 dot strip, then restaurant name, okay, parts 1 dot strip. So this is nothing, just we are trying to strip up the data from all over here, and we are storing it in a variable called item. And also if you see, if restaurant equals to next, r for r in self restaurant, if r dot name dot lower equals to restaurant name dot lower, then keep it as none. And return if not restaurant, then basically f restaurant name not found. Okay, so if I want to say what's the context of this given code is, basically we are trying to find the restaurant from the list. Okay, now after finding the restaurant from the given list, we are trying to check if the given item that we have stored all over here, it is not present in restaurant menu, then it is not part of that given order. You cannot place that given thing. Okay, so this is very important if else logic that we have added. Now let us look all over here. Okay, so order equals to order self.context, get the user, item, and restaurant. Then self.context start order, and return order placed, item from the restaurant name. Okay, so if all is okay, everything goes well, then create order, save this in this context, okay, and return the confirmation, okay, that your order has been placed. So there are certain conditions. First you need to check if this goes well, okay, then you can place the given order, and you will save this in this given context. So first you are getting the context from the user, and then there is another parameter called item, and then there is another parameter called restaurant. Okay, now we could see in the next that we have elif message equals to logout. If let's say we are getting a message logout, so if message.self.context.get user, then basically user equals to self.context.get user username, self.context logout, and return the user is logged out. Or you could say no user is currently logged in. Now you can see we have written elif message equals to logout, if self.context.get user, user equals to self.context.get user.username, self.context.logout, then we say return the user has been logged out, or no user is currently logged in. Basically, it logs out the current user via the context and returns a logout confirmation. Now you could also see the same thing all over here. If the message equals to menu, it iterates over all the restaurant basically for r in self.restaurant and returns their name and menu items in a readable format. So it's just a syntax, guys. If you are feeling bit difficulty in understanding the syntax, then you need to little bit brush up about the basics of Python. So item equals to join our menu, menus.append, r.name, r.item. Now there is another thing called help. So if the message equals to help, then basically we are returning list of all available commands that your system can understand, like login, order, status, menu, logout, and exit. So guys, as you can see all over here, we have created the protocol.py, which can be considered as the brain of our given application. Okay, so There are few parts of the thing. Okay, so we have created this based on the discussion that we did. Okay, if you are feeling any difficulty, just rewind this video a little bit backwards, understand the logic that we have discussed, then we come to this given file. So you will be much more clearer with what we are doing. Now let us look at our app.py. So app.py file is the entry point of your application. It is going to serve as the main program that ties together all the components like the model, context, and the protocol. It listens for user input, processes the command, and outputs the response. So first we are importing the given modules, like from context, import session context. So session context, this is where the session state, like who's logged in, the current order is managed, is defined basically in this file. So we are using it all over here. Then we also have something called data, and we have from data.py, we are taking get restaurant. So this function is imported from data.py file, and it returns a list of preloaded restaurant. And finally, we are also importing MCP protocol. So this is a core logic handler. So as we have explained earlier in the protocol.py, that it processes the user commands and interacts with the model and context. Now, if you could look at the main function all over here. So we have defined the main function. So there is the welcome message, okay, and there is a help prompt written all over here. Then we have initialized the component. So you could see context, session context, okay. So this creates a new instance of the session context class, which is going to track the user session and orders during the interaction. Then you could see restaurants equals to get restaurant. So it loads the list of restaurant objects which are predefined. And finally, we have initialized an empty list to store the users who log in during the session. Okay, so this is what we have done. Now let us try to understand this thing. So protocol equals to MCP protocol, and here we have context, restaurants, and user. So this creates an instance of MCP protocol, passing in the context, meaning to keep the track of the user sessions and active orders. Then you have the restaurants to validate the orders and display restaurant menus. And finally, we have users to store all the users who log in during the app session. And then there is an infinite loop for user input. Now this is pretty interesting. So we have started with while true. If message equals to input into the command .strip, if message equals to exit, print goodbye, then there is a break. Response, protocol, handle message, print response, and print. So if I would say while true, so this is the start, an infinite loop which keeps asking the user for input until they exit. Then there is message, which is asking for a prompt from the user for a command. It uses input function basically to get the command, and .strip to remove any leading or any trail spaces that we are going to have it. Then there is an exit condition all over here. If the user types exit, the program prints a goodbye message and breaks out of the loop. And also for handling the user commands, we have used this. So response equals to protocol.handle message. So this passes the user input message to the handle of the method of MCP protocol that we have created all over here, which processes a command and returns the response. And the handle method checks what type of message the command or for example the user has entered and returns the appropriate response based on the logic as we have described in protocol.py. And finally, we are running our given application. If name equals to main, then all over here we're calling our main function. So this is the entry point of the Python program. It ensures that main function will only be called if the script is executed directly, not imported as a module. Okay, so this is something like this that we have done. So in conclusion, this file ties everything together, creating necessary objects like session context, MCP protocol, continuously handling user inputs in a loop, and displaying appropriate responses based on the commands entered by the user. Now let us try to run this file. So you can open a terminal all over here, go to view, and here you can just type the new terminal. Let's run this file. Type python app.py, that is the name of given file. So you could see it is saying welcome to the food order console app, and this is the MCP style. And let's say we could log in with the user command. So if I say login, say Alice, so you could see it says logged in as Alice. Now let us type menu. So you could see we are going to get Domino's pizza, garlic bread, Burger King, burger fries, Pepsi, and from KFC we are going to get this. Now let us try to order pizza from Domino's. So this, you can see it says order placed, pizza from Domino's. Now let us check the status. You can see the order status from Domino's, it says pending. Now let's log out from this console. Okay, so this is a very interactive console that we built, a very small mini project with the help of MCP protocol. I hope so guys, you would have enjoyed our today's tutorial. Don't forget to hit the subscribe button and click the bell icon if you want to learn something amazing tutorial like this. Thank you guys for watching this video.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.